So we said that when dealing with the difference of two squares, we're talking about the subtraction, hence the difference, between two things that effectively are squared. Now, we discussed that if you've got a quadratic that looks of that form, then it's simply a case of converting this into x plus a, x minus a. We've seen that already. Okay? How do I get the x in the front bracket and the second bracket at the beginning? You just square root. Square root x squared. Okay, you square root to that. You square root the same thing to that. How do I get the a? A is the square root of a squared. So you square root a squared, you put it there, and you put it there. We then moved on to harder expressions to find the difference of two squares in my previous video. So we looked at expressions like 9x squared minus 16. We started to discuss, okay, well that 9 seems a bit of a problem. But no, it's the difference of two squares. Again, if it's the subtraction of two terms, i.e. the middle term is missing, then you just follow the same method. Square root, one bracket with a plus, one bracket with a minus. Now to square root 9x squared, you need to do it separately. You need to square root the 9, which is 3, square root the x squared, which is x. That goes in the front of both brackets. Square root 16, you get plus 4. And then minus 4 square root 16 is 4, and it goes with a plus, and it goes with a minus. Now the next logical stage with the difference of two squares is to consider factorising an expression that actually isn't necessarily squared. But the point is, the difference of two squares is something that can be square rooted. It doesn't have to be necessarily the power 2. So let's take, for example, 81x to the power 4 minus 1. Now, to do this, you're going to square root this and square root this because it's the difference of two squares. Okay, it's the difference of two things. So to factorise it, you have to try, where possible, to square root either side, one with a plus and one with a minus. Now, if you square root 81x to the 4, well, let's see, you square root 81, we do it separately, that's 9. Square root x to the 4 is x squared. And then that would be also 9x squared. Let's take a step back for a minute. I showed you in a previous video that when square rooting x to a power, any power, is half the power. That's why I've written x squared. To remind you of that, well, we can easily see that x squared times itself would be x to the 4. Therefore, the square root of x to the 4 must be x squared, just like 4 times 4 is 16. And we know that the square root of 16 is the number that times itself to give 16. I see x squared times itself gives x to the 4. Therefore, the square root of x to the 4 is x squared. And therefore, if you're square rooting x to any power, all you have to do is basically half the power. I went into detail on this in my previous video, and at the end of the video, there's going to be a link to that video. So I suggest watching it again, or watching it if you haven't watched it already. Okay, so square root of 81 is 9. Square root of x to the 4 is half the power x squared. Square root of 1 is easy. Square root of 1 is 1. So 1 goes with a plus, and 1 goes with a minus. At this point, it's tempting to stop. Right, we do not stop. Now in this bracket, we don't have the difference of two squares. Okay, I've mentioned before that this rule of the difference of two squares only applies if it's literally the difference. If it's the minus, two things being minus. This bracket suddenly now is 9x squared plus 1. It's a plus. And if the middle term is missing with a plus, there's nothing we can do at any level. Therefore, 9x squared plus 1 we can leave alone. The difference of two squares only applies if you're dealing with a minus in between the two terms. Now, over here though, that is also the difference of two squares again. We have to keep on going. So 9x squared plus 1, that will be part of our answer. That's not going to change. But 9x squared minus 1, we could actually factorise that further. You have to keep on going until your brackets are completely factorised. So 9x squared minus 1 is like the example over here. It's basically the same, it was just without the 16. So like that one, okay, 9x squared minus 1, what do we do to factorise square root either side? Square root 9x squared, that's 3 from the 9. X squared square roots to x. Okay, well, there's two brackets. 1 square roots to 1, so that's a plus 1, and that's a minus 1. Again, we can't factorise 3x plus 1, that's simple. Now, 3x minus 1, okay, is a linear bracket. Okay, when you've got linear brackets, we are happy. Okay, so we cannot do anything else to each of these brackets. Okay, some of you may ask, well, why don't we keep on going? This is a power of 1. Why don't we half that power, square it, so it would be in the power of the half? So the rule is, in factorising, we don't want any fractional powers or any decimal powers. Notice, look, the powers have to be whole numbers. So therefore, that's our final answer. Okay, so sometimes you have to keep on going with this one. You have to factorise once, and then within the factorisation, that certain brackets can factorise further. An interesting example is x to the power of 6 minus 64. Okay, let's see what happens this time. You may want to pause the video and give this one a go, and let's see if you match what I get. So maybe pause the video and have a go, and come back and let's see if you got it right. So once again, it's the difference of two terms, therefore I can try and do the difference of two squares. So let's try and square root this. Now we know square rooting x to the power of 6 is half that power, x cubed, at the front of both brackets. The square root of 64 is 8, so 1 takes a plus 8, 1 takes a minus 8. Now, that's a plus, so that bracket I'm definitely not going to touch, that's going to stay. This one here is actually also complete, unlike the other example. Why? Because the other example I had squared there. Now when it's squared there and you square root, half of 2 goes down to 1, so it's just x. But if I try to square root x cubed, I'm forced to write x to the power of 1.5, or x to the 3 over 2. Now there, that's a problem. Factorising, like I just said a minute ago, the x's have to have integer powers, whole number powers. We're not interested in writing x to the 3 over 2. Also, where would I stop? I'd square it so it would be x to the 3 over 2, then it would go to 3 over 4, then 3 over... I'd go on forever, right? I'd end up with millions of infinitely many brackets, okay? So clearly, you have to keep on going until it stops. Now, that wouldn't stop in that case. So that's the answer to the factorisation of that one. So actually, it's quite simple. So the other type of difference of two squares, which sometimes causes problems for some people, is the following example. Let's say you're trying to factorise 3x squared minus 12. Got a problem here. Okay, it's a difference. So I'm going to have to try and square root both sides and do one with a plus and one with a minus. But the problem is I can't square root 3. Right? Square root 3 would literally be root 3. If I square root 12, that would be root 12. We can see later how we can break down root 12 into something else. But the point is, I would be forced to have square roots in a bracket. Now with factorising, we don't like to do that. Like I just said, we don't want like fractional powers of x in factorising. We also don't like square roots. So we don't do that. But there is a way of overcoming this. So what you need to identify here is that before you start, you have to recognise, there's a common factor. 3 and 12 have a factor of 3. So you must take it out. Before, we had things like 16 and 9. Okay, there's no common factors there. 3 and 12 have a common factor. So what you do before you begin is take out a factor of 3. Okay? So take out a factor of 3, just like you would have done with easy factorising. If I take a factor of 3, that would be x squared. And because that's 12, 12 divided by 3 is 4. So I've got a factor of 3. Now I can do this. Right, that's something I can do. So we do 3, and this one is an easy one, and then you just do it like normal, x plus 2x minus 2. And all it means is that in the front there's going to be a number 3. That's fine. So based on that, why don't you give this example a go? 50p squared minus 18y squared. Why don't you try and find the difference of two squares there? Why don't you try and factorise that? Okay, so let's go through it. Okay, so if you try to square root this, you get a problem. Square root of 50 is you're going to be left with what's called a surd, a square root. The same with 18. But before we start, let's recognise 50 and 18 have a common factor. They both have a factor of 2. So let's have 2, take out 2, 25p squared minus 9y squared. You know you're in business when, if after you've taken out the factor, you've got numbers that you can square root. So let's take out 2. And now we can do it. Square root of 25 we can do, that's 5. And square root of p squared is just p, half the power of 2 is just 1, so it's just p. Okay, and the same in the second bracket. 9y squared we can do. Square root of 9 is 3. Square root of y squared is y. As always, one with a plus, one with a minus. And there we have it. So potentially the hardest type of complete of a difference of two squares is when you've got something like this, where the thing that's being squared is actually another bracket. So why don't you try and apply the same principle and see if you can have a go at this question. So let's go through this. Okay, again, it's a minus, so therefore, if it's a minus of two things, to factorise it, you have to try somehow to square root both sides, put one in bracket with a plus, one bracket with a minus. The problem is to square root each of these things is quite a mission. So if I want to square root this, well, let's do the easy bit. 25, I don't have to take a factor. 25 and 9 don't have a factor, and 25 and 9 both square root perfectly fine. So 25 square roots to 5. Now, this bracket squared, just like x squared square roots to x, so this whole bracket squared would square root to just the bracket, 3x minus 2. Remember, square rooting just halves the power, or in the case of squared, it just gets rid of that power. So the square root of that would be 5, 3x minus 2. Here, similarly, the square root of 9 would be 3, and the square root of, again, of this bracket squared would just be the bracket, x plus 1. Now we know, when you square root each side, the two things, one goes with a plus, and then the second bracket, they go with a minus. All we need to do now is sort this mess out. Okay, it's quite within the bracket with a little bit of expanding. This is quite a nice example. You're factorising this, but on the way to factorising, you've got to do a little bit of expanding brackets. This is how the examiners like to mix expanding and factorising. So let's expand this out. So we get 5 times 3x, that's 15x, minus 10, because it's again, 3 times x is plus 3x, 3 times 1 is plus 3, that's the first bracket, I still can go further with that, times the second bracket, 15x over there, 5 times 2 is 10, minus 10, that's minus 3x, and then minus 3. And then finally, let's sort this out, 15x plus 3x is 18x, minus 10 plus 3 is minus 7, that's the first bracket done, 15x minus 3x is 12x, minus 10 minus 3 is minus 13.